Okay, Math 2, folks. Here's your Module 1819 practice test. First is just a question of terminology. So you need to make sure you refer back to your notes here. And every time you encounter one of these things, I would encourage you to practice this by naming it. So if I said, oh, BOC here, I would go, oh, that's BOC. That's a central angle. So every one of these, I'd encourage you to use the vocabulary. Educational experts actually tell us that using language is the best way to learn it rather than just look at it. But you may want to develop some flashcards if that's a study habit for you. Before I start writing anything down, just a reminder that the best way to study for this test is to try and refer to your notes. The other handout that went with this was the explanations. You're going to learn it way better if you try and work through it using those explanation questions, and then check your answers in your work using this video. If you only watch this video as a start, you're really shortchanging yourself. You're not going to get the learning experience out of it. And if you don't learn it, then your test is going to reflect that. All right, AB doesn't go through the center, touches the ends. This is a chord. BE forms a right angle with a radius. So this means it only touches once. So this is a tangent. CAB is an inscribed angle. BED is a circumscribed angle because it's two tangents. BOD is a central angle. Let's see, what else might I test you on? I also might test you on whether you can name an arc. So AB would be an arc. We haven't done much about major arcs or minor arcs, so I'm not going to test you on that. But if you just know that an arc means the thing outside, and it's notated like this. All right, BD and AC are diameters, so find the measure of each of the following angles and arcs. I told you in class that this needs to be changed to 106 degrees. So when I'm first encountering a circle diagram like this in geometry, I'm going to be looking for inscribed angles. Here's an inscribed angle, BAD. So its intercepted arc is AD. That means this is going to be twice that, or 64. Here's an arc with BC. It has an inscribed angle, so that's going to be half of that, or 42. That means this is also going to be 42. This is also going to be 32. Notice that I'm just drawing lots of conclusions. I haven't even looked and see what I'm supposed to find out. BOC. Well, these are two diameters, which means they run right through the center, which means they must meet there right at the center. So BOC is going to be the same measure as the arc, 84, because this is a central angle, not an inscribed angle. Arc CD is going to be 106. So I'm just saying, can you take this angle and tell me that the arc is the same measure as the central angle? Measure AD is 64. Arc AD is 64. I got that from this inscribed angle. And BOA is going to be 106. Okay, that's what you need to be able to do for that first one. Second one, we say that this is a diameter. We know it's a diameter. This is 24, and this is AB is 18. That means this is a right angle, so I've got a right triangle. Solve for the remaining side in all angles. So when we solve for triangle sides, we can use the Pythagorean theorem. So 24 squared equals 18 squared plus, we'll call this A squared. A squared equals 252. It's not a perfect square, so A squared equals 252 Oh, that's all right. I wrote that. A equals the square root of 252. So let's see, that I can divide that by 2 again. This is going to be 2 times 63. 63 is going to be divisible by 9. 9 times 7, and this is 3 and 3. So I've got 2, 3, and 7. So this is equal to the square root of 2 times 2 times 3 times 3 times 7. There's my pairs. Square root of 4 times the square root of 9 times the square root of 7. 4 times square root of 4 is 2. Square root of 9 is 3. So this is 6 times the square root of 7. CAB. Measure CAB is 90 degrees. Measure ABC. So now I'm dealing with 3 sides and a right angle. How do I find the other angles? This is where trigonometry is going to come into effect. So I'm going to say this is this angle, so I'll say cosine of ABC equals adjacent 18 over 24. So that means ABC is going to be the inverse cosine of 18 over 24. Inverse cosine. So this equals 41.4. On your test, I will make sure I specify how many decimal places you are to round to. So that is measure ABC. Measure ACB. We could do cosine, sine, or tangent. I'm actually going to use, for this, I'm going to use sine. I'll write it over here. Sine of ACB is opposite over hypotenuse. So that's going to be 18 over 24. Notice that this is cosine because it's this angle. And so the cosine of this angle is the same as the sine of this angle. So I'm going to go 18 divided by 24. But since I'm taking the inverse cosine and not the inverse sine, I'm going to get a different answer. So don't assume that just because I used sine and cosine and it's the same fraction that, oh, the answer is going to be the same. Cosine and sine are different trig functions. So if I take the inverse sine of this, it's going to be 48.6 degrees. Okay? And good news, 41.4 plus 48.6 equals 90 plus 90 equals, 90 plus 90 equals 180. So all my angles add up to 180. That's good. So here's my answers here. 48.6 degrees, 41.4 degrees, 90 degrees, and 6 times the square root of 7. O is the center of the circle shown. Okay, that means that, let's see, I have to solve for QP and QMN. So if O is the center, that's good because it means I've got a central angle here. Since I know that these two sides are congruent, that means their intersected arcs are also congruent. So I've got 160 and 160. This is the center, it means this is the diameter. This is splitting it totally in half, which means I've got 180 here and 180 here, which means this is 20 degrees here and 20 degrees here, which means that this is 20 degrees there. So QP is 20 degrees. Now it says what's QMN? Well, QMN is going to be inscribed from this. This whole thing right here is 40 degrees because it's 20 plus 20. So this is going to be 20 degrees. So they actually are both 20 degrees. I gave you this correction in class, but as the diagram says, CB is 12. Find the diameter of the circle. Okay. If we see these as being opposite angles of a quadrilateral, we can say, oh, the opposite angles are equal to 180, so 2y is equal to 180. So y is equal to 90. So this is a 90-degree angle. This is a 90-degree angle. And just like we saw over here, these 90-degree angles happen when they inscribe a diameter. So that must mean if I were to draw a dotted line here, that would be the diameter. So line DB, even though it wasn't drawn in, that is the diameter. So that's going to be helpful when I come to find the diameter. Now I also have to find x. So I'm going to notice that this arc is arc ADC is equal to 5x plus x, which is 6x. So therefore, its inscribed angle, measure of angle ABC, is 3x. So now I've got ADC and ABC. 3x plus 3x must equal 180. This is the other pair of angles in a quadrilateral, inscribed quadrilateral, that when I add them together equals 180 degrees. 6x equals 180, x equals 30. So this must be 30, which means this must be 15 degrees, this angle. This must be 5 times 3, 150 degrees, so this must be 75 degrees. Is that right? 5 times 30. Yes. So I'm just noticing here, if this is 3x, this is 90 degrees, so actually I have 90 degrees all the way around. But what I have is a inscribed quadrilateral. So I'm going to say, let's see, x is 30, y is 90. So to find the diameter, I need a 15 degree, I've got a 15 degree and 15 degree angle and a side of 12, and I'm trying to find this. Now we need to notice that this is across from the right angle, so this is the hypotenuse. So I'm going to say that cosine of 15 is equal to the adjacent over the hypotenuse. I'll use h. So the diameter is going to be what the hypotenuse is. That's going to be 12 divided by cosine 15. 12 divided by 15 cosine equals 12.42. Okay. All right, so there we have it. That is number 5. Let's go to number 6. Number 6, what would FG, the length of FG have to be for it to be a tangent? So a tangent is going to be one that makes a right angle. So we have to say, okay, what would this have to be in order for this to be a right angle? So two things we can draw from the diagram. This is a right angle because it says tangent, and if this is a radius, then therefore this must also be a radius. So I've got a right triangle with 10 and 5. And I have to find the third length. Now you can use the Pythagorean theorem for this, but I would hope that at least some of you are going to be able to say, wait a minute, I've seen this pattern before. This is the other half of an equilateral triangle, which means that FG would be equal to 5 times the square root of 3. It's a 30, 60, 90 triangle. So what is the measure of FGE? 30 degrees. What would measure of arc BC have to be for the diameter of the circle to be 10 square root of 2? Okay, so if the diameter of the circle is 10 square root of 2, right, this would be 10 and 10. What I'm really testing here is, can you recognize that if this were 10 square root of 2, then this would be a 45, 45, 90 triangle. So ADB would be 45 degrees. So if this is a 90-degree angle, that means this is a 180-degree arc. That means BC must be 180 minus 115. (180 minus 115) equals 65 degrees. Okay? So on your test, I'm going to have questions that ask you to put together your knowledge of tangents and special right triangles and inscribed angles and special right triangles. So you can always use the Pythagorean theorem. So if you were to, if you want to be on the lookout for, if it says diameter, you're going to say, well, that means an inscribed angle is going to be 90 degrees. That's a key concept for this. A tangent, you're also going to be looking for 90 degrees. So tangents and diameters are have a lot to do with trigonometry, with the Pythagorean theorem, with special right triangles, because they all have right angles embedded in them. Last but not least, number 10. Let's see. The measure of BED is 200. So this whole thing is 200. What is the measure of BAC? Okay. So I have a tangent here. This is a tangent, it's 15. Therefore, if this is 15, this is also a tangent. So I've got right triangles here. This is 200, which means that from here to here is going to be 160 degrees, which means that this is going to be an 80-degree angle. So if this is 80 degrees, this is 90 degrees. That means that this is going to be, subtract it, and this is going to be 10 degrees. So this is a 10 degree. And then it says, what is the radius of the circle? So that's going to be, again, trigonometry. I'm going to say that we'll take this angle, and from this angle, I know the opposite. I don't know the hypotenuse, that's here, but I don't have to figure that out. I'm going to say tangent of 80 is opposite 15 over adjacent. We'll call this R, the radius. Now, I could also write an equation based on this. That would be the sine, no, not the sine, excuse me. That would be the tangent of 10 is opposite radius over adjacent 15. But in both these cases, I'm doing opposite and adjacent because it's the hypotenuse that I don't know. I've been given no length for that. So this will work either way. 15 divided by tan of 80. R is 2.6. I'll show you if I do 15 times tangent of 10, I get 2.6. So it works either way. All right, there is your review. So key concepts to keep in mind. Obviously, what the vocabulary is. We make frequently use of inscribed angles. So when we have an inscribed angle, its arc is twice that. We make frequent use of the principle that a diameter, if we inscribe an angle in a diameter, it's going to be a 90-degree triangle. We also do a couple of these other things about circles, about if we've got congruent chords, then the arcs are congruent, the properties of inscribed quadrilaterals, and then all this stuff with right triangles. So right triangles, we had a worksheet on that, about how we've got the Pythagorean theorem, we've got sine, cosine, and tangent, we've got special right triangles. Those are such a key concept, I wanted to make sure we put them all together in this test. Well, I hope you do well studying. Make sure you complete all your homework and check your answers. And I encourage you, if working through this was difficult, get yourself another copy and try working through it again after you've already seen the key. See if you can do these from scratch without just looking at it because that's going to give you some more independent practice. I'll see you in class, and good luck.